Now let's start chapter 3. Chapter 3 discusses quite a few things related to atoms, and it will introduce one of the most important piece of equipment ever designed in chemistry, periodic table. Atoms. We first introduced the concept of an atom in chapter 1. Atoms are the smallest particles inside an element that still possess the properties of the element. However, atoms are still divisible. There are smaller particles inside an atom. Those particles are called subatomic particles. A subatomic particle is a very small particle that is a building block for atoms. Well, so far, more than 200 kinds of subatomic particles have been detected. Luckily for us in this class, we only need to focus on 3 of them. Those 3 types of subatomic particles are electron. An electron is found outside the nucleus. So from this statement, we kind of can infer that, there is a center in the atom that is called a nucleus. What are in there? We don't know yet, but there are electrons outside the nucleus. Each electron possesses a negative charge, and electron, among the 3 types of subatomic particles, electrons have the smallest mass. Proton is found in the nucleus. Okay, now we introduced one particle that is in the nucleus. It is positively charged. The quantity of the charge of each proton is the same as the negative charge of the electron. So an electron and a proton, they carry about the same amount of charge, but opposite in sign. Neutron, also found in the nucleus, no charge. Neutron has the same mass, about the same mass as a proton. Some facts about electron, proton, neutron summarized in this table. The first row is charge. So if the amount of charge carried by an electron is specified as 1, then electron is -1, proton is +1, neutron no charge. Then the actual mass was written as scientific notation. Those are very small numbers. If you feel like it's not that easy to visualize the difference among the masses of the 3, let's look at their relative masses. If the mass of electron is 1, then the mass of a proton or a neutron is close to about 2,000 times as heavy as an electron. Talking about these 2, the difference is very small, okay, about the same. With neutron is tiny bit higher in mass than a proton. Now let's talk about the nucleus. The nucleus is small compared with the overall size of the atom. The radius of a nucleus is about 10,000 times smaller than the radius of an atom. The size of atoms is defined by the movement of electrons. So this statement tells us the nucleus is at the center of an atom. It is very small. Electrons are in the outside, they're moving, and they create the size of an atom. I'm going to try to draw a model of an atom based on this statement so far. I'm hesitating a little bit on how to draw the electrons. All right, this is what I'm going to do. This is a model of an atom I'm drawing. The lines outside the nucleus I drew, they do not represent any individual electron or electrons. They represent the movement of those electrons. And the area they created by their movement is the overall size of an atom. Compared to the size of the overall atom, the nucleus in the center is extremely small. How much smaller? In general, that's how much smaller it is. Well, you might not have seen any model of an atom being drawn in this way, but this is what we can do right now based on our current knowledge. The nucleus is extremely dense. Almost all the mass is in the nucleus. Makes sense because inside the nucleus we have protons and neutrons, and each one of them is about 2,000 times as heavy as an electron. It is positively charged. Makes sense too because it carries protons. An atom is a neutral. That tells us an atom as a whole is neutral. That tells us the number of protons equals the number of electrons inside an atom. Couple more terminologies related to protons, neutrons, atom. Atomic number. Atomic number is the number of protons inside an atom. Mass number. Mass number is the sum of the number of protons and neutrons inside an atom. Make sure you understand that this concept is called a mass number. It is not the mass. It is not the true mass of an atom. It is the number of protons and neutrons, which makes sense because almost all the mass of an atom is from the protons and neutrons, and which are about the same, which carry about the same amount of mass. Now we have this atomic number, mass number defined. We have a new way to represent an element. Okay, we call it a complete chemical symbol. This symbol tells us almost everything about an atom. You will still write the elemental symbol as what you learned before. And on the upper left corner, you're going to write the mass number, okay, which is the total number of protons and neutrons. At the bottom left, you're going to indicate the atomic number, which is the number of protons and electrons. Okay, number of protons equals the number of electrons. For example, here we have one complete chemical symbol of sodium. Once we see this symbol, we will know right away sodium will have 11 protons. Protons equals electrons, so it will also have 11 electrons. What about the neutron? Okay, the total number of proton and neutrons is 23. 23 minus proton will give us the number of neutrons. So the complete chemical symbol tells us right away the number of protons, neutrons, electrons inside an atom. Let's do a couple practice before we move on. So let's try to figure out how many protons, neutrons, electrons are there in this fluorine. Okay, number of protons right away, 9 protons, atomic number. Once you know the number of protons, you know the number of electrons, 9. They are the same thing. Okay, the number of electrons equals the number of protons. Then the number of neutrons will be the mass number minus the atomic number number of protons, which will be 10. So this element has 9 protons, 9 electrons, and 10 neutrons. Another one, gold, okay, protons, right away, 79 protons, right away, 79 electrons, neutrons, mass number, minus the number of protons, that will give us 118 neutrons. We're actually almost done with this section. However, let's go back to the definition of element again, because now we learn more about atoms. So now an element can be defined as a pure substance in which all atoms present have the same atomic number. Same kind of atoms. Atoms with the same atomic number are same kind of atoms. All atoms with the same atomic number have the same chemical properties and are atoms of the same element. Atoms with the same atomic number have the same chemical properties. Doesn't this statement kind of telling you that the number of protons is closely related to the chemical property of the atoms? It sounds like that. However, as a matter of fact, the chemical properties of an element is not decided by the number of protons. It is decided actually by the number of electrons. Electrons decide the behavior of an element. Electrons are troublemaker. Keep that in mind. We're going to quickly see that in the following lectures. See you next time.